Hi students, so after solving the numericals on Laplace transform of integral, let's move ahead with more numericals because guys, in this numerical I am gonna take a different type of function and let's see how to get the value of Laplace transform by using Laplace transform of integral. So here we have to find out the Laplace transform of t to the power minus 1 integral 0 to t e to the power minus u sin u du. Now guys, how to get the answer? So first of all, since the integration is from 0 to t, we can be sure that this sum should be solved by Laplace transform of integral. But what about t raised to minus 1 term which is outside the integration? So guys, I am going to adjust that term. So t raised to minus 1 is nothing but 1 upon t. So if I write this function properly, then this will give me Laplace of, here I'll write down Laplace of t to the power minus 1 integral 0 to t e to the power minus u sin u du equal to Laplace of integral 0 to t e to the power minus u sin u du whole upon t. So what I did here is I've adjusted this t. So guys, now if I'll see this sum, then it is also matching with division by t property. So t is coming in the denominator. So how to get it? So if I want to apply this division by t property, then accordingly this numerator will become f of t. So I'll show you. In division by t property, the numerator is called as f of t and denominator is treated as t. So we have to find out Laplace of that f of t, which is numerator, and we will call it as phi of s, and we will use that phi of s to get the final answer. So guys, here I'll say, here f of t is nothing but integral 0 to t e to the power minus u sin u du, and the Laplace of this is gonna give me phi of s, which I'm gonna use in the property to get the final answer. So let's start with that. So how to get Laplace of this? So Laplace transform of f of t is nothing but Laplace transform of integral 0 to t e to the power minus u sin u du. Now guys, this bracket is exactly matching with Laplace transform of integral property. Let me show you that the integral is from 0 to t. We have function of u du, and this is what the exact form of Laplace transform of integral, that's integration 0 to t f of u du. So from that f of u, which is nothing but our f of t, we are going to find out phi of s, and that phi of s will be using in the property. So guys, this is e raised to minus u sin u is our f of u. So we will find Laplace for that. So therefore Laplace of e to the power minus u sin u equal to. Now to get the Laplace of this, again if I observe, then it is first shifting property. So guys, just imagine we had started with division by t property, then we observed that this function is Laplace transform integral, and now we observe that this function of u, here again there is a first shifting property. So it means in one question we are using three different properties. So let's find out Laplace of this. So by first shifting property, the Laplace transform is given by phi of s plus 1, because here value of a is minus 1, so that will become plus 1. But to get phi of s plus 1, we will require phi of s. So how to get it? So here I'll say where the phi of s is Laplace of this function which is sin u, or you can say sin t, and it is nothing but 1 upon s square plus 1. So in this function I'm gonna replace s with s plus 1. So this will become 1 upon s plus 1 the whole square plus 1. And guys, this is nothing but the Laplace transform of e raised to minus u sin u. Now why do we want Laplace of this? Because we can use this Laplace in the Laplace transform of integral property. So according to Laplace transform of integral property, this phi of s is nothing but Laplace of f of u, which is f of t. So here f of u is this function, I got Laplace of that. Let's call it as some other function or by some other name. So I'll call it as, let's say, psi of s. And now here I will use the property that is Laplace transform of integral. So using Laplace transform of integral property, the Laplace of integration 0 to t e to the power minus u sin u du is equal to 1 upon s into psi of s. Now guys, the value of psi of s is this, so I'll put that value there and we will get answer as 1 upon s into s plus 1 the whole square plus 1. So guys, we got Laplace for this function, and if you observe carefully, then that function is our f of t, and if it is f of t, which is a numerator, then we are gonna use its Laplace for division by t property. So now I got Laplace of this numerator, you can observe here, and now I'll divide by t, so it becomes division by t property. So here I'll say using division by t property, Laplace of integral 0 to t e to the power minus u sin u du whole upon t is equal to integral s to infinity into phi of s, which is nothing but Laplace of this function of t. So Laplace of this is this given function, so I'll write down that. So 1 upon s into this value is s plus 1 the whole square plus 1 into ds. So now guys, last step, that is the integration of this term. So integration of this term is gonna give us the answer for our question. So for that, let's simplify this term. So this will be integration s to infinity 1 upon s, here it is s square plus 2s plus 1 that is plus 2 ds. And now to get the integration of this, we are going to use integration by partial fraction. So there are two terms in the denominator which are multiplying each other, both are algebraic equations. So by integration by partial fraction, I'll find out the partial fraction first and then I'll put the value over here. So let's call this as equation number 1 and let's find out the partial fraction of this function. So here I'll say by partial fraction 1 upon s into s square plus 2s plus 2 equal to, so it is nothing but a by s plus bs plus c upon s square plus 2s plus 2, and let's call this as equation number 2. Now let's do the cross multiplication. So here we will get a into s square plus 2s plus 2 plus bs plus c into s upon multiplication of these two terms, but it will be cancelled with these two terms. So here we will just get 1 and I'll call this as equation number 3. Now guys, in this equation number 3 we will put different values of s to get the value of a, b and c. So let's put s equal to 0 in equation number 3 we will get 1 equal to 0, 0, 2, so that is 2a. S is 0, whole term is 0. So therefore we got a equal to 1 by 2. Next, let's find out second value, and for that let's put s equal to 1 in equation number 3. So we'll get 1 equal to a, which is half, s is 1, so 1 plus 2 that is 5, s is 1, so we will get plus b plus c. So here we got 5 by 2, we'll send it here, so that will become b plus c equal to 1 minus 5 by 2, and that will give us minus 3 by 2. Now let's call this as equation number 4. Now similarly I'll find one more equation b in c. So for that let's put s equal to minus 1 in equation number 3. So this will become 1 equal to, now minus 1 square is 1, a is half, here minus 1 square is 1, so 1, here we will get minus 2 plus 2 cancel, so we'll just get 1. Again s is minus 1, so here it is minus 1 into, this will be minus b due to s is minus 1, so minus b into minus 1 is plus b, and c into minus 1 is minus c. So guys, this is half, so half will go there and that will become minus half. So we will get b minus c equal to 1 minus half, that is half, and this is nothing but equation number 5. So now guys, we will solve equation number 4 and 5. So in 4 b plus c is minus 3 by 2, in 4 b minus c is this, and by adding it we will get value of b. So adding 4 and 5, we will get 2b equal to, this is minus 3 by 2 and this is 1 by 2, so that will be minus 2 by 2, which is equal to minus 1, and guys therefore we will get value of b as minus 1 upon 2. Similarly we'll find out value of c by putting this value of b in 5 or 4. So from equation number 5 we will get minus half minus c equal to half. C will go here, will become positive, half will come here, will become negative, so minus half and minus half is minus 1. So guys therefore the value of c is minus 1. So here I got value of b and c. So guys, what you can do is, after finding equation number 4 and 5, you can put these two equations in calc to get the value of b and c. But instead of that, even if you solve, these are the basic equation, you can get answer in 1 or 2 steps. So I got b and c. Now we'll put these values of a, b and c in equation number 2. So from 2 we will get 1 upon s square plus 2s plus 2 equal to, now a upon s, a is half, so that will become 1 upon 2s, b is minus half, c is minus 1. If I put it here, so minus half and minus 1, I can take minus sign common, so minus sign outside, here we will get s by 2 plus 1 upon s square plus 2s plus 2, and guys this is nothing but the value of this function. So now I can replace this function with the value we got. So here we will get the final answer, that is Laplace of this given function of t by t is equal to integral s to infinity these two functions, that is 1 upon 2s minus s by 2 plus 1 upon s square plus 2s plus 2 into ds. Now guys, to find out the integration of this, it's simple, because 1 by 2 outside, integration of 1 by s is log s, but here to get the integration we have to adjust the terms. So what I'll do is, here I will cross multiply it. So we will get integration s to infinity 1 by 2s minus s plus 2 upon 2. So 2 will come in the denominator, and here we will get s square plus 2s plus 2 into ds. Now guys, 1 by 2 I can take it common from both the terms. And now to get the integration of this term, I'll be using a property f dash of x upon f of x. So the derivative of this is 2s plus 2. So I'll try to bring 2s plus 2 here, and for that I'll multiply and divide by 2. So guys, here we will get integration s to infinity 1 by s, because I've taken 1 by 2 outside. From here also I've taken 1 by 2 outside, minus, now I'll multiply with 2. So we'll get 2s plus 4, and we will divide by 2 also. So again one more 2, s square plus 2s plus 2 into ds. Now guys, you can observe that the derivative of this term is 2s plus 2, so I got 2s plus 4. Now I'll split that 4 into 2 parts. So 2s plus 2 plus 2. So this will become 1 by 2 integration s to infinity 1 upon s minus, this is 1 by 2 into 2s plus 2 upon s square plus 2s plus 2, next minus 1 by 2 again, and here one more 2 is remaining, so 2 into s square plus 2s plus 2 into ds. And now let's find out the integration. So I'm cancelling this 2 with 2. So we will get 1 by 2, the integration of first term is log s, minus, if I find the integration of second term, then I'll take 1 by 2 constant outside, and here I'll apply the property of f dash of x upon f of x. So that will give me log of s square plus 2s plus 2. Next, here to get the integration of this, I'll rewrite this term as, here I'll show you, 1 upon s plus 1 the whole square plus 1. See here, s square plus 2s plus 1 is nothing but s plus 1 the whole square, and remaining 1 is plus 1. And for this I'll find out the integration, which is nothing but minus tan inverse of s plus 1, and this is from s to infinity. Now guys, let's take these two terms together, and to apply the property of log a minus log b, what I'll do is I'll multiply and divide this term by 2. So by doing that, here we will get half. This will become half into 2 times log s, which is nothing but log of s square, minus half log of s square plus 2s plus 2 minus tan inverse of s plus 1 from s to infinity. Now this is nothing but half common. This is log a minus log b, which is log a upon b. So log of s square upon s square plus 2s plus 2 minus tan inverse of s plus 1 from s to infinity. Now let's put upper and lower limit. So upper limit is infinity. So guys, if I put infinity over here, I'll get infinity upon infinity, which is indeterminate form. So to remove the indeterminate form, I'll do few adjustments, and I'll try to bring that infinity in the denominator, because we know that some number upon infinity is equal to 0. So for that, what I'll do is I'll divide numerator and denominator by s square. So this will become half, in bracket, half into log of, if I divide by s square, I'll get 1 here, I'll get 1 here, plus 2 upon s plus 2 upon s square minus tan inverse of s plus 1, and from s to infinity. Now let's put upper limit. So half as it is, By substituting the upper limit, that is infinity, we will get half 2 upon infinity 0, 2 upon infinity square 0, 1 plus 0 is 1 and 1 upon 1 is 1. So we will get log of 1. And if I put infinity here, tan inverse of infinity is pi upon 2. So here I have substituted upper limit. Then middle sign minus. Now let's put the lower limit. Now lower limit is s. So if I put s equal to s, it makes no difference. I'll get the same value. It means I'll get this value. So it is half log of s square upon s square plus 2s plus 2 minus tan inverse of s plus 1. Now log of 1 is 0, so this first term will be 0. Here I'll get negative pi by 2, so it is equal to half in bracket negative pi by 2. Here we will get negative half, so minus half log of s square upon s square plus 2s plus 2, and here minus and minus will become plus tan inverse of s plus 1. Now from these three terms I can take negative sign common, so minus half will be outside. We will get pi by 2 positive. Tan inverse will become negative, so minus tan inverse of s plus 1, and this minus will become plus half log of s square upon s square plus 2s plus 2. And now for these first two terms I am going to use a property of inverse trigonometric function, that is pi by 2 minus tan inverse theta is equal to cot inverse theta. So this will become minus half in bracket cot inverse of s plus 1 plus half log of s square upon s square plus 2s plus 2. And guys, this is nothing but the value of given function. So this is the Laplace transform of this given function. So I'm sure that you understood that how I've applied three properties together and we got the Laplace transform for given function. So for more videos, keep watching ekeda.com, where you can find all videos of all engineering subjects together. Thank you very much.